Hello dear students, welcome back to our YouTube channel. As you know that we are studying about integral transform, in which we are studying about Laplace transform. In previous lecture we have seen the definition of Laplace transform as Laplace transform of f of t is equals to integration from 0 to infinity e raised to minus st f of t dt, correct? And we have found some results for basic function such as Laplace transform of 1 is 1 upon s, then Laplace transform of t raised to n is n factorial upon s raised to n plus 1, then Laplace transform of e raised to at is equals to 1 upon s minus a, then sine of at is equals to a upon s square plus a square, and Laplace transform of cos at is equals to s upon s square plus a square. After that we have seen the properties of Laplace transform, properties of Laplace transform, in which we have seen about the first property, that is linearity property. The second one is shifting property. In which we have two properties. First one is force shifting property, and second one is secant shifting property. In previous lecture we have seen the first shifting property, that is force shifting property. The Laplace transform of C1 f1 of t plus C2 f2 of t. Linearity property first. Linearity property, we have C1 f1 of t plus C2 f2 of t is equals to C1 f1 of s plus C2 f2 of s. Correct. Then we have seen forced shifting property, which is given as Laplace transform of e raised to at f of t is equals to f of s minus a. Correct. Now we have secant shifting property. Secant shifting property. Today we are going to prove the secant shifting property, and the statement is as follows: if theorem, if Laplace transform of f of t is equals to f of s, correct, then and g of s is equals to f of t minus a, f of t minus a, and 0 whenever t is positive, and t is negative. Correct. T is greater than a and t is less than a. Then Laplace transform of g of t is equals to e raised to minus as f of s. Here we have g of t. Correct. Theorem is given as if Laplace transform of f of t is equals to f of s, and g of t is given as f of t minus a whenever t is greater than a, and 0 whenever t is less than a, then Laplace transform of g of t is equals to e raised to as into f of s. So we will try to prove this property, since we know that by the definition Laplace transform of f of t is equals to integration from 0 to infinity e raised to minus st f of t dt. Correct. Now, since here we have to find the Laplace transform of g of t, therefore left hand side is equals to Laplace transform of g of t, and which is equals to integration from 0 to infinity e raised to minus st g of t d. Correct. But g of t has two different values for different interval. So we can divide this interval into two parts. That is integration from 0 to a e raised to minus st, and whenever t is less than a, we will get 0 at the place of g of t dt, plus a to infinity we have f of t minus let's write it as small f of t minus e raised to minus st f of t minus a dt. Correct? Whenever t is greater than a. Now, since we have 0 here, after multiplying 0 with e raised to minus st, it becomes 0, and we will get 0 plus integration from a to infinity e raised to minus st f of t minus a dt. Now put t minus a is equals to p. This implies that t is equals to a plus t, and if we differentiate we will get dt is equals to dp. Correct? And whenever we put the value of t, when t is equals to a, this implies that t is equals to a minus a becomes 0, and when t is equals to infinity, this implies that infinity minus a again infinity. So we can replace this equation as e raised to integration from 0 to infinity e raised to minus s, and t is replaced by a plus t. F of t minus a means t minus a means p, f of p, and dt equals to dp. Correct? And as t running from a to infinity, t is running from 0 to infinity, so we have the interval integration from 0 to infinity. Now we can simplify this integration 0 to infinity e raised to minus sa into e raised to minus st f of t dt. And since e raised to minus sa is free from the parameter p, so we can consider this e raised to minus sa or e raised to minus as a constant, and we can take it outside from the integral, and we will write it as e raised to minus as integration from 0 to infinity e raised to minus st f of t dt. Correct? Now we can write this equation as e raised to minus as f of p, and if we replace this p by s parameter, so we can write it as e raised to minus as f of s, and capital F of s. So we have the second shifting property as Laplace transform of g of t, where g of t is equals to f of t minus a whenever t is greater than a, and 0 whenever t is less than a, is equals to e raised to minus as into f of s. And we have proved the second shifting property in this lecture. Now from next lecture we will see some more basic properties such as change of scalar property. Then we will see the Laplace transform of derivative, and after that we will see Laplace transform of integral and Laplace transform of multiplication of power of t in next lecture. Till then, keep watching our video and stay tuned with us. Thank you.